Hello and good afternoon, CTS267 Section 840 students for the Spring 2017 semester at Anne Arundel Community College. This is the CCNP TSHOOT course, and this afternoon's video tutorial is really going to be sort of an expansion on the conversation we had regarding the Null0 route that you see being auto-magically installed into your routing table when you're doing any kind of summarization. And so this was Evan had a really good question on Thursday night regarding this, and I wanted to make sure that we capture the semantics behind what is happening. And we'll take a look at it from both a BGP as well as we'll use one of the IGP, so we'll use EIGRP and do summarization there. And I'm also going to go a little deeper in terms of performing the manual summarization. How can you manually summarize things and still create you can create a static route that for the aggregate that is going to point toward Null0, and then you're able to advertise that summary. So here we are in router 1. We've got a show IP BGP summary. So we've got a neighbor relationship form with router 2. You can see we don't have any prefixes exchanged, right? And so let's take a look at show IP interface brief. Show IP interface brief. And I think we've got some loopback addresses here. We do. So when we take a look at these loopback addresses, and we're going to be using these three in our BGP scenario here when we create this Null0 route. Let me get the pin back up. So first thing we want to do is real briefly just go ahead and summarize what these three routes, or how we're going to represent these three routes. So we know the first octet is the same, the second octet is the same, and then we get to the interesting octet, right? The third octet, where the values are no longer the same. And so what do we have? We've got 32, 33, and 34. So 32 in binary would be 0, 0, 1, 0, and then 0, 0, 0, 0. And then it's pretty easy from here, right? Because we know the position is this value of the bit position, or the bit position value is 32. So to get 33, we just need to add 1. To get 34, we would add 2, and then we can just backfill 0, 1, 0, 0, and then 0, 0, 1, 0, 0, 0, 1, 0. So now that we've got the binary representation of the interesting octet, we now, again, we begin our search going from left to right. Up here we were doing it looking at the octets, right? Now we're doing it going left to right looking at the bit position. So as long as we're all the same, it's good. So we're the same, the same, the same. We're good, we're good, we're good. And then we get right here, right, where we are no longer the same, right? The bit position values change here in the 7th bit position of what is ultimately going to be the third octet. So what value do we have over here? Well, we look at the last set of bit positions that had the same value. If these were all zeros, then it would be .0. But that's clearly not the case, right? Because we've got 32. The bit position for 32 is on, so we know that it's going to be .32. Now, what else do we know? Remember, we can sort of back our way into how many subnets the summary is actually, or how many networks the summary is actually supposed to represent. So if you were to take 2 to the number of bit positions that don't match here, so 2 to the 2 is 4. Well, we're only showing 3 networks, and I'm doing this intentionally so that we've got the final network. And what would that final network be? So the bit positions, we've got 0, 0, 0, 1, 1, 0. What's the only other combination we can have here? Exactly, 1, 1, which would be 32, 33, 34, 35. So .35 is the network that we're missing. In other words, we're missing 10.32, .35.0, and I think I made these all slash 24s. But we'll check on that. It's kind of irrelevant here in this conversation. But, so we know that we're representing 4 networks, and what is our summary going to be? Well, how many bit positions matched in addition to the first octet, the second octet, so it's 8 and 8. So we've got 16 bits that already match, and then we've got 17, 18, 19, 20, 21, 22. So we know that the summary that we're going to be working with, and I'll write that over here, is going to be 10.32.32.0/22. And what this means is this summary is representing all 4 of the networks in question. These 3 and the 10.32.35 network. And this is very important, right? And so this is kind of the first step toward understanding what this null0 route is about. So you can clearly see here that I have longer, more specific matches that are going to be in my routing table for these 3 networks right here. I do not have a longer, more specific match for this network. Again, that network doesn't exist in the routing table on router 1. But the summary that we came up with, right, which is the most accurate summary that we could get in a single summary statement for 10.32.32.0/22, again, this is actually representative of the 3 networks here and that 4th network, which doesn't exist, right? And so this is key, and I'm stressing that because this is where the whole concept and the premise behind the null0 route comes into play. So how are we going to do this? So let's take a look at this from the BGP perspective. So here's the information again. So in fact, let me write down to the side here real quick, 10.32.32.0/22. And real quickly, if it's a 22, we know that it's going to be 255 for the subnet mask would be 255.255. What? Well, 128.196. Because it's again 128 and 64, 196, 224, 240, 248, 252. 252.0. So that is the subnet mask, right? All right, so let's clear the screen here. And let's approach this from the BGP perspective, because we were talking about the Jeff Doyle book where he does what we call manual BGP summarization. Well, how would I do manual BGP summarization? Well, remember, to advertise something in BGP, we need to have a network statement. So how would we do that? We would go into global config. I would say router BGP1 because I'm on router 1. And I've got a couple of ways I can do this. But again, if I wanted to list all 4 of the networks, then I'm not really summarizing, right? And again, we're going to focus on the manual summarization here. So to manually summarize, I would say network, right? And remember, this is different than the aggregate address command that we talked about in the route course. So this is a network statement. I'm going to be advertising 10.32.32.0 followed by the subnet mask. And so we're going to advertise the summary network. And you can see here we've got this network 10.32.32.0, and that was a subnet mask. And we know that that represents 10.32.32, 33, 34, and 35. So I type this network statement in. But when we come over to router 2, right, and I say show IP BGP, I don't have anything. What about and in fact, let's do this real quickly. Let me say interface loopback 0, IP address 1.1.1.1, and then we'll make it a 32, so that we have something here. And then let's say router BGP1 network 1.1.1. Trying to go too quick. All right, remember the subnet mask needs to match exactly. So now when I come over to router 2, what do we see? Okay, so again, I just threw the 1.1.1.1 in there so that we can see that BGP is working, right? It's doing exactly what it's supposed to do. But this begs the question, where is my network? Where's my summary for the 10.32.32? Where is that? Well, remember, BGP has a requirement, right, that when I indicate that I'm advertising a network and the mask, subnet mask value, the network and the subnet mask value, not only do they have to be exact, but I need to have these in my routing table somewhere. So let's take a look. Do show IP route. Do we see anything for, and again, not for the members, not for the components, because I'm not advertising the components. I'm advertising the summary network, right? And again, we're doing manual summarization. Because if you're sitting there screaming, hey, why aren't you using the aggregate address command? Again, this is an alternate way to achieve the same thing. And we will get to the aggregate address command, but right now we're doing a manual summarization. I've got my network statement that represents the summary network, but I don't have in my routing table a network that matches exactly that subnet and that subnet mask length. I have the component, I have the member networks here, right? I've got the member entries and those are directly connected and that's great. But BGP's requirement is they need to match exactly. So what do? What do you think you can do in order to create an entry in the RIB, right, the Global Routing Information Database, so that this will actually be advertised? Exactly. We can simply do a static route. So I can say IP route 10.32.32.0 255, wait, where am I at here? Yeah, 252.0. So I'm creating a static route that says, in order to get to the destination 10.32.32.0 with a /22 subnet mask, or when traffic is coming into me going to this network, where am I going to send that traffic? So I could tell it to go out and interface. However, remember, we're doing manual summarization. And so here's our first look from a manual perspective. This is where we would create the null entry, or I'm sorry, the null0 entry. So I'm basically saying that I'm going to create this static route for the 10.32.32.0 /22, but I'm pointing it at null0. So what does that mean? Well, remember, we're advertising that summary, but what is the network that's included in the summary that we do not have? Do show IP route. And now in the routing table, here is the static entry, and it's pointing to null0. And so what this means is when we receive traffic, due to the fact that we're advertising that summary, which means 32, the 32 network, that 33 network, the 34 network, and the 35 network, right? That if we receive traffic for which we do not have a longer, more specific match, which you will with the 32, the 33, and the 34, but not the 35, that the traffic that we're receiving, because we are advertising, right? We have a static route that says, hey, we know how to get to these different networks. But we truly don't know how to get to the 35. It just happens to be a component network that falls under the summary that we created. So when traffic comes into router 1, and router 1 says, it's destined to the 10.32.35, it looks in its routing table, its RIB, recognizes that, hey, I don't have anything for the 35. Where does it get sent? To null0, which is just what we refer to commonly as the bit bucket, right? It's a Unix term. The bit bucket, which is a black hole. It's just dropped. So now the question becomes, well, why do you have to create the null0 network? And again, you don't have to, but here's the use case that it's preventing or protecting you against. So, and actually let me, I can do this. I'll leave that on the screen there, and we'll roll over here to router 2. So now on router 2, when I say show IP BGP, now take a look at the two networks that I'm receiving. So now router 2 is under the impression that in order to get to any of the networks in the 1032.32/22, which we know to be 32, 33, 34, and 35, right? In order to get to any of those four networks, my next hop is who? It's router 1. So router 2 will send all of its traffic for those 4/24s that we're looking at over to router 1. But router 1 for the .35 says if I get any traffic for the 35, I'm dumping it because I don't actually have a valid, longer, more specific match or any network statement for the 1032.35. So in other words, router 1 is basically pretending, right, or I guess to say representing himself, right? Router 1 is representing himself saying, hey, router 2, I know how to get to the 32, the 33, the 34, and the 35. So if you've got traffic, send it to me for those four networks. If you have traffic for any of those four network segments, send it to me. Router 2 says, great, here's a bunch of traffic for the .35. Router 1 gets it and says, oh, yeah, about that. So I know I'm representing myself as being able to reach all four of those networks. However, I don't actually, I don't actually know how to get to the 35. I don't have an entry for that. Even though I'm telling you that I do with this summary statement, I don't. So I'm just going to drop it. So here's what the Null0 interface, right? Hopefully you understand what I'm explained here, is the Null0 interface is now dropping by design, right? And as it's supposed to, because we don't have the 35 network. So router 2 sends the traffic over for the .35. Router 1 says, oh, I know I said that I knew how to get there, but I don't actually have a network entry for that. I'm dumping it in the bit bucket. It's going to Null0. That's why we create that Null0 entry, because here's what could happen excuse me, without the Null0 entry for the summary. Router 2 sends traffic for the .35 network over here. Router 1, which let's pretend doesn't have the Null0 entry, says, yeah, you know, I don't have a more specific network for that, but you know what? I have a default route configured that tells me to send all traffic that I don't know where to send over to you, router 2. So router 1 then would send it over to router 2. So here comes that .35 network. Router 2 gets the traffic for the .35, and what does he say? Exactly. Router 2 looks into his routing table and says, well, lo and behold, I have a summary advertisement for 1032.32.0/22, and it's telling me that I send the traffic back over to you, router 1, who router 1 then gets the traffic and says, you know what, I don't have the null entry because we're pretending it's not there. Router 1 then gets it and says, nope, I'm sending it right back to you. That's what my default route tells me to do. And then 2 gets it back to 1, 1 gets it over to 2, and then we go to the TTL, right, of 255 until that traffic actually drops in our network. Now, with this simple scenario here between two routers, not that big of a deal, but if you've got, you know, thousands of clients hanging off here and they're all trying to hit the 1032.35, and this is the scenario, you're going to have all kinds of traffic looping in your network until the TTL expires and the traffic is dropped. And that is the purpose of that Null0 route. That's why we create that Null0 route, is to protect against scenarios like that. So now that router 2 has the advertisement for the summary, if he was to try to, and let's see, I don't know if we have the routing on the other side, 32.35.1. Yeah, I don't have the network information configured on the other side. I'm sorry. Actually, this should work. 34. There we go. So the 35.1, that should not work, right? Because what's happening? Exactly. The traffic is being dropped into the null 0 interface, and so it doesn't work. But the other networks do. The 1032.34, the 1032.33, and the 1032.32. And those all work. What if I do a network that's outside? How about 36? So take a look at the difference in the ping output. Because 36 is not represented by that summary. Remember, that summary represents 4 and only 4 networks. The 32, 33, 34, and 35. So when we try to go to a network that that summary represents, but that is being dropped by the null interface, that is the output we end up with. We end up with the periods because, again, we don't even have, the traffic's not going anywhere. We have no network for the 1032.36. But here we do, and we forward the traffic over to router 1 only to see that the traffic is ultimately dropped because it's going to the null 0 interface. So we looked at manual summarization, right? And what is manual summarization? Do show run section router BGP. So instead of saying aggregate address, I create my own static route. Do show run include IP route. Right? So there's my static. So I'm going to create a static route, right? So that I have something in the rib, and that entry is going to point to null 0, because only then am I going to be able to put in the network statement under BGP that represents that summary. And so this is, again, this is a great way in a small environment to sort of tackle this approach. So now let's go ahead and let's sort this out. We're going to say, excuse me, actually we'll just say, yeah, let me go in there. So we'll say router BGP1, and I'm going to say no network. So we're going to remove this. So we remove the manual summarization, and actually let me get rid of the static route as well, just to be sure. And so we're removing that entry from the rib. If I come over here to router 2, and we say show IP BGP summary, or actually just show IP BGP, what do we have? Exactly. So BGP withdrew that summary as soon as we pulled the static route out, because it's no longer in the routing table, the global rib, which means the BGP process says, I don't actually have that route. So then I'm going to withdraw the advertisement for the network statement because I don't actually have an entry for this in the global rib. So now let's talk about, and did we already do that? There we go. So now let's talk about, excuse me, the aggregate address command, right? So the opposite of the manual summarization would be the sort of automatic summarization using the aggregate address command. And so in order to do that, we would simply do show IP BGP. So here's what we see in BGP right now. So if I say router BGP1 and I say aggregate address, and what is the address? Well, it's 10.32.32.0 followed by the mask. And so here are a bunch of options, right? We've got an advertise map, AS confed set, AS set to keep the path information with the prefixes. We can do an attribute map, apply a route map, do the summary only. And we talked about this on Thursday, that these, you sort of lose access to these. The route map is still there. When you do that IP route on the static route to null 0, when you're doing manual summarization, you can still apply a route map. But we lose sort of the summary only aspect of things if we only wanted the summary to go, or a suppress map to possibly allow certain prefixes to be suppressed. So again, these are options that when you do manual summarization aren't there. So here's the aggregate address command, and I hit enter. So are we going to see it over here on router 2? And the answer is no, we are not, right? And why not? And this is this is where we get into the semantics of BGP. Remember, with the manual summarization, we had to have an entry in the global rib in order for the network command to allow BGP to advertise that network being advertised with a network statement. With the aggregate address command, the requirement is different because we have the entry in the routing table for the component or the members of this aggregate. And real quickly, aggregate and summary are synonymous, right? I'm using them as synonymous terms because they perform the same task, right? We're summarizing. It's just that BGP calls it aggregation or aggregate. So again, with the aggregate address command, the requirement isn't that we have an entry in the rib or show IP route. It's not that we have an entry in the rib, right? So what if I were to do this? If I were to say IP route 10.32.35.0 255.255.252.0 to null 0. Oh, whoops! Did I? Do I have a typo there? 10.32.35.0 255.255.252.0. Am I missing something here? Yeah, no, that should. Or wait, am I on the right router? I am on the right router. Oh, I got the wrong. Yeah, I put 35 for some reason, and I wanted 32. It took me a minute to catch that. So, but anyway, back to the semantics of BGP. With manual summarization and a network statement under the BGP global config section, then it gets advertised. When you're doing the aggregate, when you're using the aggregate address command and you have a statement there, does it advertise it? Let's come over here and see that it does not. Because the aggregate address command, which is creating that summary that we're going to be advertising, that 10.32.32.0/22, the aggregate address command requires that at least one of the member routes be in the BGP rib, right? Or you'll hear it referred to as the BGP routing table. But BGP has its own table. So do show IP BGP. This is how you see it. And this is where we're looking. So at least one member route has to be in the BGP rib, not the global rib, right? That's where we had to have that the static route pointing to null 0 for the network statement to work with manual summarization. With the aggregate address command, it's not good enough just to have that static route. This is not going to do anything because that doesn't show up in the BGP rib. This is showing up, and I'm got this typo again. Let me get this typo out. Because again, this isn't going to show up in the BGP rib. That is showing up in the global routing table, right? So what do we have to do? Well, how do we get the NLRI, the network layer reachability information, a fancy way to say the prefix and the prefix length, right? So the 1111/32, this is the NLRI. How do we get that into the BGP rib, at least one of them, so that this aggregate statement will work? Exactly. We simply use the network command, and we say, and again, the mask has to match, so do show run int loopback 32. And okay, so they're /32s. So we would say network 10.32.32.0 mask 255. Actually, let's drop that in there. And I think I need to do the .1. I'm drawing a complete blank right now. Yeah, I needed the exact match in there. So again, it's got to match exactly. So let's put in the .1 and we'll get rid of that 32. There we go. All right, so now under our BGP config section, do show run section router BGP. We see we've got our aggregate address command and we have a network statement, right? And remember, the requirement for the network statement is that there's an entry for that in the global rib. Do show IP route. Do we have a 10.32.32.1? We do. And now look what we have. Now we have the aggregate showing up here, but look what auto-magically happened that we had to manually create with the manual summarization. What is auto-magically here? Null0. And so the reason the routing protocols do this is to protect you from the scenario where you may be pointing a default route right back at a router that's sending traffic to you for a network that you are saying you represent and that you are saying that you have reachability to get to, that you really don't. And I can't pull this out. The only way for me to get rid of that Null0 route is to pull the summary out. I can't, there's no command for me to simply just remove have this not point to Null0, right? BGP auto-magically puts that in there for you. So when I come over here to router 2, and now we rerun the show IP BGP command, there you go, right? So not only do we get the summary, but we also get the components or the members that make up that summary. Now remember what I said. You have to have at least one component member in the BGP rib, or the summary will not be advertised. And so let's simulate that. So, and this is one of the drawbacks I was telling you about when you configure an aggregate address command. If you only enter a single network, what happens when interface loopback 32, which is do show run section router BGP, so that's the single network command. Now remember, there's two other networks that we have, 33 and 34. But I decided, I'm the network engineer, and let's say I decided I'm going to take the shortcut here. That I know you only need to have one entry in there, and this network never goes down. So I'm just going to use 3232, right up until the point that network 32 goes down. And again, I'm using loopback addresses to simulate the network segments. But if we lost that entry, and it could be an entry that we're receiving from another router for that matter, if we lose this network, right, from our global rib, what do you think is going to happen to the summary that is depending upon this network being in the global rib? Because remember, with BGP, the network statement, it's not going to put it in the BGP rib, which is where the aggregate address command needs it, unless the network statement finds it in the global rib. So now we take a look at router 2. Let's rerun this command here, and gone, right? So that is definitely a pitfall that you, a snafu, that you don't want to encounter. So what's the solution to this? Well, the solution would be that we go to router BGP, and we say network 10.32.33.1. And the mask option I forgot, so we'll say mask, and then we'll pull that back up and change it to 34. And there we go. So now we come back to router 2. We've added these two additional routes in, and you can see there we go. Now it's interesting, the 34 doesn't show up, and my guess, and before we even look, my guess is that I used a different subnet mask on 34, not a /32. So let's pull that out. It's my guess, or I just didn't wait long enough. Do show run interface loopback 34. It's probably a /24. Okay, I didn't wait long enough. So let's put the 32, 34 one back in there, and we'll see if it comes over. We should see all the components that make up, and could be something else here. Let's say do clear IP BGP star out. And was I just not patient enough? BGP catches me. All right, so something else is going on with the 10.32.34. Do show IP interface brief. So a little troubleshooting time here. So the 32 is down. 32.34.1 is up. Do show run section router BGP. Why don't we see the 34.1? And the mask is correct. So that's interesting because we should be seeing... Of course, Murphy's Law. The toughest problem to troubleshoot is the one that doesn't exist. So I was BGP, it's just very slow, and it makes me very impatient. So it was there. So we have what? We've got the summary or the aggregate advertisement, and we have the member advertisements. But most importantly, do show IP route. What do we have in the RIB, in the global routing table? We have the BGP summary route that points to Null0. And again, to prevent us from sort of shooting ourselves in the foot and ending up with traffic that we say we have, we know how to get to the destination, that we actually do not. All right, so again, great question, Evan, and hopefully this has cleared up the Null0. With EIGRP, it's the exact same thing. And so we could do the same thing with EIGRP, and you are going to see when you do the IP EIGRP summary address command, you're going to see an EIGRP entry for the summary to Null0. And OSPF does the same thing when you do the area range, right? All right. Thanks so much for watching, guys. Enjoy spring break, and I will see you in 2 weeks.